So the rectangle that is not actually a rectangle, but we're going to assume it is because it says that it is. And the reason why I said it's not actually one, even though it looks really, really close, is because this is 2 over 3 as a slope, and the other slope is negative 7 over 5, and those are not perpendicular. But we're just going to go with this. So, if we're given this side, we need to find each side length. So we're going to use Pythagorean theorem, 2 squared plus 3 squared equals c squared. This would give us 4 plus 9, and that is the square root of 13 is the c. So square root of 13, and it does say round to the nearest tenth, which is 3.6. So 2 of these sides is 3.6. The other 2 sides, we got 5 squared plus 7 squared equals c squared. We got 25 plus 49. And if you add those together, it's, let's see, 674. So square root 74 and round to the nearest tenth is 8.6. So 2 sides are 8.6 and the other side is 3.6. If we want the perimeter, we add up all 4 sides. So 3.6 plus 3.6 plus 8.6 plus 8.6. And that is 24.4 units perimeter. Now if we want the area, we do base times height. We multiply the two together and get 31.0 units if you round to the nearest tenth. And that would be units squared because it's multiplying the two together. Okay, what's the shortest distance between the hospital and the stadium? The hospital is down here and the stadium is here. So shortest distance is not to go rise and run, but to go straight. But if we want to know the length of how far you go, we have to count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And use Pythagorean theorem. 7 squared plus 4 squared equals c squared. And because notice I do have a 90-degree right here, so this side is c. This is 49 plus 16. And that is square root of 65 units. It doesn't actually say to round, so we could just say square root 65 units. That's the exact answer. Or if you round it to the nearest tenth, just like we did on the last one, it'd be 8.1 units. Okay, last part is constructions. Construct an equilateral triangle inscribed in a circle using only a compass and straight edge. So the first thing we need is a circle. And I'm going to get this compass back out. So if we draw a circle and we want to, what we're going to do is, if we make a hexagon and then we skip every other one, that's going to give us a triangle. So the way that we did the hexagon is first we started at a point and then we put the pencil in the middle and we swung it through. And every time we hit the circle, we take our compass again and swing it through. So I'm going to go around the circle just like this, bringing it in, pencil on the center, swing it through. Got to turn this first on this next one. Point, pencil in the center, and swing it through. Oops. Point, gotta drop it down. Point lined up, pencil in the center, and swing it through. Point, pencil in the center, and swing it through, and it should cross exactly where we started. So if I connect each of the 6 points on the outside, I would have a regular hexagon. If I connect every other one, I end up with a triangle that is equilateral. So this is my inscribed in a circle equilateral triangle. Okay, number 16, construct the perpendicular bisector of the line segment that passes through the given point. For this one here, okay, construct the perpendicular. This should be construct the perpendicular line to the line segment that passes through the given point. So we are going to draw a line through this point that's given, and it's going to be perpendicular to that line drawn. So we are going to take our compass, we're going to put the point on the point that we're given, and we're going to take our pencil. It can be an arc of any size that you want, as long as when you swing it through, it crosses through 2 spots on the line. So we got that. And you don't have to draw a full circle, right? So we could just draw to there, right? We don't have to draw that whole thing. So we're going to, next, we're going to put the point where we intersected the line. And I'm going to line this up so that it matches the other side, point to point. You don't have to go point to point. As long as you go more than halfway, it doesn't matter. It'll still work out. So I'm going to swing it through, and I want to swing it through up high and down low. So like that, and then I'm going to switch it, and I'm going to keep my compass setting so it's still through that point where I already crossed through, and I want to swing it through so that it intersects both the curve of where I just crossed over. And I'm going to draw the line now. We've got it from point to point, and if I draw that line segment from point to point, notice, well, it's a little bit off, but notice it crosses right through that point that we wanted to cross through. So what we've done is we drew a line. This is our line right here that is perpendicular to the line given, this is given, through this point that was also given. Okay, last one. Copy the angle using only a compass and straight edge. So to copy an angle, we have to copy onto something. So I'm going to start with a point, and I'm going to draw a line segment out here. It can be anywhere, okay? I can draw the line anywhere. I'm going to just draw it like that. Then the next thing, we're going to put our compass, line up our tip at the vertex of our angle, and I can put my pencil anywhere as long as it's going to cross through the angle in 2 places. So I've got that. I'm going to keep my setting exactly what it is. Don't change your setting. And we're going to take that same arc and swing it through over here. We're copying that arc we just made. And then we're going to drag our compass back over and we're going to go point to point. Here we do have to change the setting. So we're going to go up here, line up our pencil right on where we intersect. Okay, and we're going to swing it through from there. Okay, and then we're going to drag over and copy that. Notice I'm lining my point up with my intersection. And I'm going to copy that same mark, that same arc over here. And where the intersection got placed, right here, is now where I connect from vertex to the intersection point. And now this angle here is the copied angle. These two angles have the exact same measurement. We just copied the angle.